Okay, so let's untack this. We are diving deep into a subject that I think sits right at the intersection of um, chemistry, our daily habits, and a pretty major financial investment. And that's the state of your kitchen. Most of us, and I'm absolutely including myself here, we operate under this kind of fundamental delusion when it comes to cleaning.
It really is the ultimate cognitive bias we have in our own homes. I mean, you, the listener, you look at a clear counter, you've swept the floor, and you think, okay, mission accomplished.
Uh,
Everything is aesthetically pleasing.
right, it looks clean.
It looks clean. But the sources we've compiled from professional restoration and cleaning experts, they are all completely unified on this one point.
Mhm.
What you see is a lie. Your kitchen is slowly, silently aging itself. It's turning that vibrant space you moved into a dull, sticky one.
And that's the core tension we're tackling in this deep dive. The mission today isn't just about basic hygiene. It's about moving beyond that surface wipe down, the one that's purely for aesthetics, and getting into true restoration. We're talking about embracing the deep clean as a necessary strategy to maintain and really protect your massive investment.
Exactly. I mean, just think about the assets you purchase for your kitchen. You have expensive engineered quartz, maybe natural granite, all those stainless steel appliances, custom finished wood cabinetry. These are not static materials. They are under a continuous chemical assault from 3 major enemies generated just by daily use.
Okay, what are they?
Sustained heat, pervasive moisture, and, this is the big one, organic matter, the little remnants of the food we cook every day. Surface cleaning only deals with that transient, visible dirt. Deep cleaning, or what we're calling restoration, that's what actively reverses the decay process. It directly influences the longevity and, honestly, the resale value of your home.
And when you frame it in terms of longevity, the difference between that $1,000 fridge burning out in 7 years versus lasting 20, the stakes are suddenly very, very high. So if we agree that a quick wipe just isn't enough, we have to identify the invisible enemy that defeats our efforts. I mean, if standard soap and water cuts through kitchen grease on a dinner plate, why is this invisible enemy in the room itself so much harder to conquer? Is it fundamentally different?
It is fundamentally different, and it comes down to 2 things: concentration and time. When you wash a plate, you have high friction, you have hot water, and a high concentration of detergent acting immediately on a fresh spill.
Right, it's instant.
It's instant. But in the kitchen environment, the enemy has time to mature.
Yeah.
It has time to build defenses. So we absolutely need to understand the physics of grease and the biology of all that buildup.
That's where we need to start.
Okay, so beneath that superficially clear surface, the one that looks clean at arm's length, is what one of our sources so vividly calls a microscopic city. This is a complex, sticky layer, and it's composed of 3 key elements. You've got cooking grease aerosols.
Those are the tiny particles of oil that go airborne when you're cooking.
Exactly. Then you have carbonized food particles, the tiny specks that fly off the stovetop, and finally, vast colonies of bacteria. This persistent, invisible layer is the real source of that premature dullness, the slight stickiness, and those low-grade odors we just assume are part of having an older kitchen.
And the reason our typical cleaning methods, like, that grocery store spray bottle and a paper towel, the reason they fail isn't just about concentration. It's about a defense mechanism the microbes are using.
It's highly strategic. The bacteria and fungi create what is scientifically known as a biofilm.
A biofilm.
And this isn't just a layer of gunk. It's a meticulously engineered, sticky, protective coating. It's a polysaccharide matrix, essentially.
Like a fortress wall made of sugar.
Pretty much. Think of it as a fortress wall built entirely out of sugar and protein polymers. This film shields the microbes living underneath from all kinds of environmental stressors, including your average cleaning sprays.
Wait, so we're not just moving germs around. We're actively spraying a disinfectant on a fortified structure and expecting it to just dissolve the walls instantly.
That's precisely the situation. When you grab that standard neutral pH store-bought cleaner and you spray it on your kitchen's surface, the liquid, it just glazes right over the top of the biofilm. It doesn't penetrate that protective coating nearly fast enough to kill the bacteria inside or dissolve the structure itself. And this leads directly to the homeowner's #1 mistake. The mistake of speed.
The classic spray and immediately wipe maneuver.
Yeah.
I am still so guilty of trying to be too efficient with this. If I'm doing that, what am I actually accomplishing?
You've achieved aesthetic satisfaction, and you've moved the germs around in a wet, diluted circle.
Oh, great.
In terms of sanitation, you've accomplished virtually nothing against the established bacterial colonies. To break that biofilm, the chemical equation has to change. First, the product needs the right pH balance, often highly alkaline for grease, or maybe specific enzyme cleaners designed to digest the organic proteins. Second, and this is crucial, it needs sufficient dwell time.
Dwell time. Okay, if we're talking about a serious deep clean, how long we're realistically talking? Are we setting a timer here or just being patient?
Patience is key, but timing is critical depending on the product's strength. For many professional-grade degreasers or sanitizers, they need a bare minimum of 30 seconds just to start the penetration process. For tougher, established biofilms, like, say, on the inside of a trash can lid or a greasy backsplash, you might need 5 to 10 minutes.
Wow, 10 minutes.
Yeah. The chemical action, the bite that dissolves the polymer fortress, it just cannot be rushed. If you are wiping within 5 seconds of spraying, you have effectively wasted the product's active ingredients and you've just done a surface rinse.
That is incredibly actionable. Dwell time is the silent partner in chemical cleaning. But okay, the biofilm is a biological defense. Let's talk about the physical, structural challenge that grease presents, especially in areas we rarely even look at. The physics of polymerized grease.
This is where cooking oil becomes a physical problem. When we cook, especially frying or sautéing, microscopic aerosols of oil are released into the air. This airborne cooking oil eventually settles on every single surface, but it's most noticeable on vertical surfaces and, critically, the tops of your upper cabinets.
You touch the top of the cabinet and it just feels sticky. We call that dust, but it's not just dust, is it?
Absolutely not. That stickiness is the physical evidence of chemistry in action. The airborne cooking oil, which is a liquid, has bonded or polymerized with household dust, with carbon particles, and moisture. Polymerization is the chemical process where monomers, like the individual oil molecules, link together to form these long, stable polymer chains.
So it's turning into a plastic almost.
Essentially, yes. The liquid oil has oxidized and cured, turning into a hard, plastic-like residue. It's kitchen glue.
So if polymerization is turning oil into plastic, does that mean our standard solvents, like mild dish soap or alcohol-based cleaners, are mostly useless against it?
They are essentially useless. They just smear the plasticized grease around. You cannot break that thick, tacky glue with a damp cloth or a standard dusting spray. It's too well bonded. I once saw a cabinet top in a commercial kitchen where the polymerized grease layer was so thick you could literally scrape it off like brittle, dark paint chips.
Wow.
That's the result of years of cumulative plasticized buildup.
So the professional solution must require a degreaser with some very specific chemical properties. What are we looking for to safely dissolve that bond without stripping the expensive finish off, say, custom wood cabinets?
This is where you have to be careful. You need an appropriate high alkaline degreaser, often something with a pH of 12 or 13, that's formulated with saponifiers. Saponifiers turn the fatty acids in the grease back into soap, which makes them water-soluble.
But that sounds really harsh for wood.
It can be catastrophic. It
Yeah.
might strip the varnish right off. So the crucial detail here is specificity. For wood finishes, you need a degreaser that uses citrus solvents like D-limone or specialized enzymatic cleaners that are powerful enough to break the polymer chains but are explicitly labeled as safe for finished surfaces. And you must test in an inconspicuous area first. But the principle is, look for the degreaser, not the general cleaner. It has to dissolve the bond, not just lubricate it for smearing.
That distinction, the difference between smear and dissolve, is vital. I mean, it means we stop wasting time and product. Okay, we are now officially moving past the accessible surfaces and into the hidden internal organs of the kitchen, the heavy appliances. These demand specific, non-negotiable labor that the amateur homeowner often skips entirely.
And the neglect here doesn't just affect cleanliness. It actively accelerates appliance failure, which translates to massive repair or replacement costs down the line. Let's start with the refrigerator, which is, mechanically speaking, the lung of your kitchen.
I find that analogy perfect. It's constantly breathing the kitchen air to keep the food cold. So if we've already established that the air is full of dust, pet hair, and those greasy aerosols, where does the fridge collect all that particulate matter?
It collects it directly onto the condenser coils. These are usually located either behind a kickplate grill at the bottom front or sometimes completely on the back of the unit. These coils are where the refrigerant dissipates the heat that's been extracted from the interior. So when they get choked with dust and pet hair, they can't efficiently transfer that heat.
So the fridge has to work harder.
Twice as hard. It has to work twice as hard to maintain the target temperature.
And that increased thermal effort puts a huge amount of stress on the compressor. This is the difference between a high-end refrigerator lasting its 20-year engineered lifespan versus, failing catastrophically in year 7 or 8. That is a significant and entirely preventable loss of investment.
It is entirely preventable, but it requires some heavy labor. The deep clean requirement here is non-negotiable. You have to physically pull the fridge out from the wall.
The whole thing.
The whole thing. First, unplug it for safety. Then you need a long, specialized coil cleaning brush and a HEPA filter vacuum. And we can talk about why HEPA is so crucial later. You have to meticulously clear all the dust and pet hair off those coils. Ignoring this one task is the single fastest way to shorten the lifespan of the most expensive machine in your kitchen.
And while you've taken on that heavy, dirty work, the source is all stressed to look down at the floor behind the unit. This is where the real archaeology of horror begins.
Oh, it's the zone of perpetual neglect. We're talking about accidental spills milk, soda, juice that ran down the back, sealed themselves under the little rubber feet, and have just been festering for years. Our sources recount these horror stories of finding spilled orange juice from 2019 that has essentially become a permanent, moldy, sticky seal on the hardwood or linoleum.
Oh.
Not only is that a huge source of odor and insect attraction, but if that liquid is acidic, it can cause lasting damage to the flooring. This is where the meticulous nature of deep cleaning truly separates itself from a quick, weekly tidy-up.
Agreed. Okay, moving from the cold internal organ to the hot one,
Right.
the oven. The great oven dilemma centers on that seemingly magical self-clean button. It's so appealing, but professionals universally issue a very strong warning against using it.
It's the highest risk shortcut in the kitchen, without a doubt. The self-clean function works by raising the internal temperature to 800 or even 1,000 degrees Fahrenheit, which incinerates the grease and carbonized food. And while it cleans effectively, that extreme, prolonged heat often compromises the delicate electronic control board, the literal brain of the modern oven, and the thermal fuses.
If that control board fries.
That's a common, extremely expensive service call, oven costing several $100s, sometimes more than half the cost of just replacing the oven itself. The plastic components, the wiring insulation, the electronics, they're simply not designed to consistently handle that level of thermal stress.
So the preferred, safer professional method is the manual deep clean. What does that process demand in terms of thoroughness?
It requires commitment and the right chemistry, which is usually a manual application of a heavy-duty caustic degreaser, often high-pH commercial products, or, for the homeowner, a very effective paste made from baking soda and water applied to a damp surface. But the thoroughness is non-negotiable. First, you must remove the racks. They need their own specialized soaking, often in a large trash bag with ammonia or a strong degreaser, left overnight in a safe outdoor location.
And what about the glass door? That's the true tell of the oven's internal health, isn't it?
Absolutely. The glass should be scrubbed until it transforms from what we call a brown-tinted mystery, that cloudy, opaque layer of baked-on greaseback, into a clear window. The baking soda paste works beautifully here because the fine granules provide the gentle adhesion needed to scrub away the carbonized layers without scratching the glass.
And for the really tough stuff.
For truly heavy carbon buildup, professionals will sometimes use a razor blade scraper, very carefully applied, to remove the thickest deposits before moving to the chemical scrub.
That detail about the razor blade is a great insight into how aggressively you have to tackle that carbonized grease. Okay, now let's pivot to the dishwasher paradox. I think this is the #1 aha moment for most listeners. We are conditioned to believe that a machine designed to clean must, by extension, be clean itself.
And that assumption is where the health hazard lies. The dishwasher is, in fact, a breeding ground. The constant humidity, combined with moderate temperature changes, creates an ideal environment for mold and yeast, particularly in the hidden areas. Look at the rubber seals around the door, the gaskets. They constantly harbor black mold and slimy buildup that never fully dries out.
But the functional problem, the thing that makes your plates not truly sanitized, is centered on the debris recirculation.
Yes. The primary mechanical issue is the filter system. Even after you scrape your plates, tiny food particles, rice, seeds, little bits of vegetable, they get flushed into the bottom of the dishwasher and trapped in the circular filter, often called the sump filter. And that debris rots. So every single cycle, the machine is pumping water that has washed over rotting organic matter, and it's recirculating it onto your supposedly clean plates and silverware.
That is genuinely unsanitary, and it explains why dishes sometimes come out with a slight residual odor or a film. So what is the mandatory, actionable step for the learner here?
It's mandatory disassembly. You have to pull that filter out. In most modern machines, it simply twists and lifts out easily. Then you need to manually scrub it. The professional tip here is to use a stiff brush, like an old toothbrush, to get into the fine mesh and crevices where particles hide and dry. Once it's clean, replace it.
And beyond the organic gunk, we have the second major enemy of the dishwasher, hard water deposits.
Hard water minerals, calcium and magnesium scale, are ubiquitous if you live in an area with non-softened water. This mineral buildup not only reduces the heating element's efficiency, forcing the machine to draw more energy to heat the water.
But it's also why my glasses look cloudy.
It is the primary culprit behind that cloudy, etched, cheap look on your expensive glassware.
So the solution is a chemical strike specifically designed for mineral removal.
A dedicated descaler, yes. You need to run a full, empty cycle using a descaling product, often one based on citric acid, to strip that mineral deposit away. This process restores the machine's internal mechanics and ensures your glasses sparkle, protecting the aesthetics of your kitchen investment. Sanitizing the washing environment is just as crucial as scrubbing the plates.
We've established that the internal organs require intensive, specialized labor and chemical intervention. Now let's move to the external surfaces we interact with daily, the countertops and the stainless steel. This is where cleaning has to be a philosophy governed by the material itself. Using the wrong cleaner can be worse than using no cleaner at all.
This is the art of material philosophy. Understanding the specific vulnerabilities of the surface prevents permanent damage. Let's focus first on porous stones, granite and marble.
Stunningly beautiful, but notoriously high maintenance and chemically reactive.
They are porous stones, which means they have these microscopic capillaries that can absorb liquids. The wrong cleaning product doesn't just clean, it causes permanent etching. The major unforgivable mistake is using common acidic cleaners, things like vinegar, lemon juice, or even some abrasive bathroom cleaners, which homeowners often reach for as cheap natural solutions.
But on stone, they are disastrous. Why does acid cause that dulling effect, that etching?
Granite and marble contain calcium carbonate. Acid dissolves calcium carbonate. The chemical reaction literally eats away at the sealant and the polished, smooth structure of the stone, creating microscopic pits that appear to the naked eye as permanent dull spots or white marks. The only way to fix severe etching is professional repolishing, which is extremely expensive.
So the strict protocol requires a neutral pH cleaner. That's step 1.
Correct. Use products explicitly labeled for stone. Step 2, which homeowners often forget, is maintaining the invisible shield, the sealant. The sealant occupies those microscopic pores and repels stains.
And the sources give us the perfect test for the sealant's health.
The water test. You want the counter to be so well sealed that when you drop a small bead of water on the surface, it sits there perfectly rounded like a tiny raised pearl.
Okay.
If that water immediately flattens out, or worse, begins to soak into the stone, causing a slight temporary darkening, your sealant is compromised. It's gone.
And the consequence of compromised sealant is terrifying from a preservation standpoint.
You are now vulnerable to irreversible permanent stains. A dropped slice of lemon, a ring from a glass of red wine left overnight, a splatter of tomato sauce, these things will be absorbed deep into the stone structure where no amount of surface cleaning can remove them. Restoring the counter involves not just cleaning, but applying a fresh, high-quality seal and allowing it the necessary cure time. This is proactive maintenance that saves the stone.
Let's transition to the key of modern aesthetics.
Yeah.
Stainless steel. It's called stainless, yet it's the most frustrating surface to keep looking pristine.
It's a complete misnomer. It's stain-resistant, not stain-proof. It quickly accumulates fingerprints, frustrating water spots from mineral deposits, and most dangerously, it is susceptible to pitting from chloride corrosion.
From salt.
Salt. Yeah, think about the salt shaker near the stove, or cleaning with chlorine bleach, or even just splashing water near the sink. The chlorine ions attack the microscopic chromium layer that gives stainless steel its resistance.
So if stainless steel is so vulnerable, how do professionals maintain that perfect showroom shine? This brings us to the secret weapon, grain matching.
This is critical. Look closely at your appliances. You will see faint parallel lines, that is the grain of the metal, created during the finishing process. You must always, without exception, wipe with the grain.
Always.
Always. If you wipe against it, you are driving microscopic grease, dirt, and cleaning residue into the tiny valleys of the metal's texture. This causes streaking and dullness that are impossible to buff out without specialized equipment.
And the right tool is equally non-negotiable here.
Absolutely no paper towels. The wood fibers in paper towels are surprisingly abrasive and can cause fine hairline scratches over time, especially visible under certain light. Professionals use only a high-quality microfiber cloth. The entire cleaning process is a two-step ritual.
We clean with the grain and then we finish. What is the role of that finishing product?
The surgical grade polish is essential. It doesn't just add shine, it creates a microscopic hydrophobic barrier.
Hydrophobic meaning water repelling.
Exactly. This barrier actively repels the next fingerprint, the next water spot, and makes the surface far easier to maintain. That means the water beads up like mercury, making it simple to quickly wipe away the spots that would otherwise dry and create mineral etching or pitting. It's an investment in minimizing future labor.
We've covered the chemistry and the physics of the major structural components. Now let's turn our attention to what separates a superficially clean home from a truly sanitized and restored one, the forgotten zones. These are the areas that act as the litmus test for deep cleanliness.
These are the periphery spots that frame the entire room. Ignoring them makes the whole space feel perpetually heavy no matter how much effort you put into the center.
The first one is the baseboard crust. This area collects a grotesque amalgam of household debris.
It's truly awful. The
Yeah.
baseboards collect spilled liquids that run off the counter, residual floor wax, lint, and hair. Because the wall meets the floor at a 90-degree angle, standard mops or vacuum attachments can never reach into that corner effectively. The source calls this accumulated gunk a crust.
And a deep clean requires meticulous, almost uncomfortable labor.
You have to get down on your hands and knees. You need a dedicated detail brush, maybe an old toothbrush, or even a specialized flat tool like a putty knife wrapped in a damp cloth to physically scrape out the gunk from the corner. Then, use a damp microfiber cloth to remove the residue.
Why does cleaning a small strip of wood matter so much to the overall feel of the room?
It's all about framing and contrast. When the baseboards are bright and clean, especially if they are white or light-colored, they provide a crisp, clean visual boundary that frames the floor. When they are dirty and crusty, they absorb light, and the entire floor, no matter how perfectly vacuumed, looks visually weighed down, dingy, and old. It elevates the entire perceived cleanliness of the space.
Next, let's talk about the nightmare of tiled kitchens. Grout agitation.
Grout is a fascinating and annoying material. It's not smooth, it's porous. It essentially functions as a hard sponge between your tiles. And here is the great irony. Our efforts to maintain the floor are precisely what make the grout dirtier over time.
How can mopping the floor make the grout worse?
When you mop, even if you are meticulous about changing your water, you are essentially dipping a mop into water that contains diluted dirt, soap residue, and oil. When you pass that over the floor, the tiles are relatively non-porous and they shed the liquid, but the grout acts like a wick. It absorbs that diluted, dirty water into its pores. Over months and years, this perpetual absorption of dirty liquid turns originally light gray or beige grout black. It's not necessarily mold, it's just absorbed, embedded dirt.
So mopping will never fix black grout. You have to agitate the dirt out of the pores.
You must lift the dirt and then extract it. Step 1 is chemistry. You need an oxygenated cleaner, something that uses hydrogen peroxide or a specialized grout stripper that is designed to lift the dirt out of the pores. This requires significant dwell time, often 30 minutes, to bubble up the material. Step 2 is agitation. Scrubbing vigorously with a stiff, specialized grout brush. The brush physically dislodges the now lifted dirt.
And if you stop there, what happens?
The dirt just resettles as the liquid dries. The crucial third step is extraction. Professionals use a wet vacuum or a high-absorption microfiber cloth to physically pull the liquid and the dirt out of the pores. If your grout looks two different colors, you don't need a new floor. You need a strategic, deep clean focused on this agitation and extraction process.
That makes perfect sense. The goal is removing, not just moving. Finally, let's discuss the ultimate indicator of airborne grease in your kitchen, the range hood filter.
This filter is the heart of kitchen grease filtration, and if you cook with oil, that silver mesh filter above your range is almost certainly clogged solid. It may look visually intact, but if you haven't cleaned it in 6 months, it's a dense, sticky, non-functional barrier of polymerized grease and carbon.
And the mechanical consequence of that blockage is severe.
When the filter is clogged, the fan motor has nowhere to move the air. It ceases to function effectively. Smoke, grease, and those greasy aerosols we discussed don't get pulled outside. They stay airborne, eventually settling on everything else. Your curtains, the top of your fridge, your cabinets, your light fixtures.
So it becomes a systemic problem for the whole house.
A huge problem. It increases the cleaning burden everywhere. Worse, a heavily grease-laden filter can become a fire hazard.
So What's the mandatory deep clean procedure for this filter? We can't just spray it down, can we?
No. This requires immersion and heat. You have to pop those filters out, they usually slide right out with a simple latch, and soak them in a large vessel, like a utility tub or maybe the bathtub, filled with boiling hot water and a heavy concentration of industrial strength, highly alkaline degreaser, something like a TSP substitute or a potent commercial product.
And that heat, combined with the strong alkaline, is designed to saponify that heavy, plasticized grease.
Exactly. The hot water and the chemical bite break those polymer chains and turn the grease back into liquid soap. The test of success is simple and visible. After soaking, rinsing, and maybe some scrubbing, the filter must look like shiny, new, unblemished metal. If there is any lingering discoloration or sticky residue, you haven't finished the job. Achieving that level of degreasing is the defining factor in truly improving your kitchen's air quality and protecting your long-term appliance investment.
This entire discussion confirms that this level of cleaning is detailed, scientific, and physically demanding, which naturally raises the question, why do professionals consistently win this battle, and how can we, the amateur homeowner, adapt their strategies for long-term, sustained maintenance?
The professional edge is built on 3 pillars: consistency, specialized tools, and the professional eye. Let's start with consistency. The amateur cleans the oven once a year, dreading the task. The professional tackles these intensive, unpleasant tasks every single day. That muscle memory and systematic approach ensures 0 details are skipped, and the buildup never reaches the point of being overwhelming.
And the tools available to them are fundamentally different from what we can buy at the local hardware store.
They utilize industrial-grade, highly specialized chemicals formulated to handle polymerization and heavy carbon without damaging engineered surfaces. Crucially, they employ specialized equipment that directly impacts air quality and hidden debris. We're talking about powerful, specialized steam cleaners that sanitize tile, grout, and appliances at high temperatures without using any chemical residue whatsoever.
And you mentioned HEPA filter vacuums being critical for the coils. Why is that level of filtration so necessary for cleaning?
Standard vacuums are often ineffective because they just blow the finest, most irritating particles like airborne pet dander, dust mites, and carbonized aerosols right back into the air. HEPA filtration is mandatory because it captures particles as small as 0.3 microns. These are the particles you can't see, the ones that trigger allergies and build up in the mechanical systems. Professionals ensure that when dirt is lifted, it is truly removed, resulting in an immediate improvement in the home's respiratory health.
That makes perfect sense. They remove the source of the irritant, not just the visible dust bunnies. But the most insightful advantage is the eye. The professional is not accustomed to the space. They see things the owner misses.
The homeowner is acclimatized to their own dirt. You stop seeing the accumulation. The professional cleaner, on the other hand, they see the subtle drip of syrup that ran down the side of the cabinet 2 weeks ago and dried. They see the dust accumulating on the recessed light bulbs, which actively diminishes the output of the light and makes the entire kitchen feel darker and heavier, impacting your mood.
Or the calcium buildup on the faucet aerator, that tiny piece of hidden screen where the water comes out.
Precisely. That little screen gets choked with hard water deposits, which destroys your water pressure and makes the tap spray unevenly. The professional spots that immediately. These are not major tasks, but when you rectify these hundreds of small details, it completely transforms the functionality, brightness, and psychological mood of the kitchen.
And all of this circles back to the connection between deep cleaning and the sensory experience of the space, especially odor.
A truly professionally deep-cleaned kitchen smells like absolutely nothing. If you walk in and smell a strong fragrance, lemon, pine, or cinnamon, that fragrance is often just a perfume masking an underlying odor.
So where are those stale odors coming from?
They are held in the grease. Odors, like the lingering smell of last night's fried fish, are held in the complex, volatile organic compounds, or VOCs, that are trapped within that polymerized grease layer on your walls and cabinets.
So by removing the source, the physical grease, you achieve true odor neutrality and healthy air quality.
You remove the molecular source of the odor, deep cleaning the walls, the ceiling fans, the tops of the cabinets, the places where the grease deposits, dramatically improves the respiratory quality of the entire home. You achieve a true sanctuary, not one masked by chemical perfumes.
So, assuming the deep clean is successfully executed, how do we, the amateur, maintain this professional level of restoration? We need a clear, systematic maintenance cadence. Let's adopt the professional's approach.
We recommend the Dinkel analogy. Daily surface cleaning, wiping the counter, washing the dishes is like daily brushing. That is essential. But you still need that professional intervention every few months to get the embedded tartar off. That's the deep clean. The daily tools you use are critical.
And based on the sources, the #1 tool we need to throw away is the sponge.
Immediately. The sponge is, as one source calls it, a bacterial hotel. It's moist, warm, porous cellulose that harbors countless germs and just pushes diluted pathogens around your surfaces. Switch entirely to microfiber cloths and commit to washing them in high heat in a sanitizing washer cycle after every significant use. And get a simple rubber squeegee for your counters to prevent those common hard water spots from accumulating near the sink.
And let's reiterate the most important behavioral change for long-term success, which centers on that chemical process we talked about, the grease rule.
This is the rule that saves you hours of future labor. The grease rule is simple. Wipe up grease immediately while the oil is still liquid. If you fry chicken, wipe down the surrounding backsplash, stovetop, and nearby counter area right away while the oil is still warm.
Because once that oil cools, what happens?
Once it cools, it begins the process of polymerizing, curing into that plastic-like adhesive glue. Liquid oil is a quick wipe with a standard cleaner. Polymerized grease is a heavy scrub requiring alkaline chemical intervention. Adhering to this rule drastically reduces the frequency and intensity of your required deep cleaning.
That is a phenomenal, tangible rule of thumb. Liquid oil is a quick wipe. Plasticized grease is a heavy chemical scrub. Finally,
Yep.
the scheduling. If we are serious about asset protection, how often should we schedule these professional-level interventions?
For most busy households, a systematic deep clean is recommended every 3 to 6 months. If you are a heavy cook, particularly using high heat oils, or if you entertain frequently, quarterly sessions might be necessary. This cadence prevents permanent damage, the irreversible etching on the stone, the deep-set grout stains, the critical buildup in the appliance coils from ever starting. It actively protects your asset and preserves the home's value and functionality.
This deep dive has fundamentally shifted my understanding of what clean truly means. It's not about the visual, it's about the chemistry and the physics of organic decay. The ultimate takeaway is that the deep clean difference is about so much more than immediate hygiene.
It is about pride of ownership, and more profoundly, it is about peace of mind. Knowing that the surface where you prepare food is truly sanitized, not just superficially wiped, changes your fundamental relationship with your home. We covered critical, actionable lessons today, the absolute necessity of dwell time to overcome biofilm, the expensive risk of relying on the self-clean function on your oven, and the hyper-specific requirement of wiping stainless steel with the grain to maintain its integrity.
And to wrap up, let's consider the broader psychological impact. Our sources describe the kitchen as the soul of the house.
It is the gathering spot, the workspace, the center of nourishment and communication for the family.
So if the soul of the house is covered in a persistent, invisible layer of tacky, polymerized grease, a layer that is actively aging your assets, holding on to stale odors, and providing shelter for microbes, then the whole house, and perhaps even your own feeling of mental sanctuary, feels heavy and burdened.
So the provocative thought we leave you with is this. Consider how much the hidden state of your physical environment impacts your mental clarity, your energy levels, and your overall feeling of relaxation. If, as the professionals suggest, a clean home is the foundation for a clear mind, what specific psychological weight are you carrying around that is simply the byproduct of sticky cabinet tops, black grout, and a grease-choked range hood filter?
Now go forth, grab a specialized brush, find your degreaser, and start looking at your kitchen with a chemist's eye and a professional system. Thanks for diving deep with us.